Welcome to another AP podcast. This is a continuation of 4.9. Now, last time we learned about oxidation states, and so what we're going to do today is continue with that and use those oxidation states to watch the transfer of electrons. And so you can see right here, that's what a redox reaction is. And so we're just going to assign some oxidation numbers and watch what happens. So here we have sodium in its standard state. And my question to you is, well, what is the oxidation state there? Well, hopefully you'd go, oh, it's 0. And same with this one, with chlorine. Now over here, sodium's +1 and chlorine's -1. So chlorine went from 0 to -1, and sodium went from 0 to +1. If we look down here, let's assign oxidation states here. Hydrogen is +1. Carbon must be +4. Whoa, how about this? How about -4? Okay. Oxygen is 0. Over here, oxygen is -2. Carbon here is +4. Hydrogen is +1, and oxygen is -2. So you can see that carbon went from -4 to +4. Oxygen went from 0 to -2. So what has happened in both those reactions is the oxidation state of the element has changed, and that is what's typical of a redox reaction. So if you look at a couple of the terms here, oxidation is officially the loss of electrons, and reduction is the gain of electrons. Now there's a slight problem with that, right? Because look at these two words. Reduction is gain. All right, that's kind of backwards. That's kind of opposite, and that's what constantly gives students problems here. That oxidation is a loss and reduction is a gain. So there's a couple mnemonics that help you out. I learned this from high school and college. Oil rig, oxidation is loss, reduction is gain. Here's another one. Loss electrons, oxidation, gain electrons, reduction. So you've got oil rig or Leo goes grr. But what I really prefer is a number line. And a teacher taught me this a number of years ago. +1, +2, -1, -2. All right. So if the number goes up, it's oxidation. If the number goes down, it's reduction. That seems to be a lot less confusing than trying to remember what's happening to the electrons. But you probably should have a good feel for these two mnemonics just in case it comes up and you for some reason can't use the number line. So to continue on with this, oxidation means an increase of oxidation state, so it's a loss of electrons. Reduction is a decrease in oxidation state. That's a gain of electrons. So in that respect, reduction means a decrease in oxidation state, right? That makes sense. But we're gaining this negative thing, right? And that's where the opposite kind of messes people up. Now, there's a couple other terms that we need to be familiar with because this will pop up on the AP test every so often. They'll say, which one of these is the reducing agent? Or which one of these is the oxidizing agent? And year in and year out, most of my students tell me that, hey, the best way to remember it is it's the opposite. So in other words, if something gets oxidized, it's the reducing agent. And oxidizing and reducing are opposite terms in this respect, right? Or if something is reduced, it's the oxidizing agent. I had a teacher friend tell me one time, well, if you're a travel agent, you don't travel, you help someone else travel. So you might think of it that way. If you're the oxidizing agent, you don't get oxidized, you get something else oxidized. So those are two things that you've got to keep straight because there's going to be questions about those quite often. So let's try one. All right, so we've got three reactions here, and you can see up here we've got it's just some basic questions. Which one is the substance oxidized? Which is reduced? What's the oxidizing agent? What's the reducing agent? So let's just start assigning oxidation numbers here. Now, iron in the solid state, 0. Oxygen in its natural state, 0. Iron here, +3. Oxygen here, -2. All right. So as far as who gets oxidized, we'll look at oxygen. Oxygen goes from 0 to -2. Now on my number line, that's going down, right? So oxygen is getting reduced. And who gets oxidized? Well, iron's going from 0 to +3. So iron's getting oxidized. Now between these two, which one's the reducing agent and which one's the oxidizing agent? Well, iron gets oxidized, so therefore it must be the reducing agent. And oxygen gets reduced, therefore it must be the oxidizing agent. Does that make sense? We'll try the next two and see how you do. Alright, so look at those numbers, if you can read my writing, and see if that's what you've got. So in this first reaction, or the second reaction right here, iron's going from plus 3 to 0, so that is getting reduced, right? Oxygen, or carbon here, is going from plus 2 to plus 4, so that's getting oxidized. Since iron is getting reduced, it must be the oxidizing agent. And since carbon is being oxidized, it must be the reducing agent. Now, one thing I haven't mentioned that I do need to mention is that in all these cases, if one element is being reduced, one other element has to be oxidized. And that should hopefully make sense to you, because if something is losing electrons, something else has to be gaining electrons. You can't have one happen without the other. So let's look at this one. Sulfur here is plus 5. Over here, oops, I didn't finish. Sulfur would be plus 7. So that's getting oxidized, right? That means it's the reducing agent. And then manganese here is plus 7 going to plus 2. So that's getting reduced. So that is the oxidizing agent. Okay, hopefully you got that. All right, let's move on to the last little part here. Half reactions. Now, in order to balance these things, it's going to be real beneficial for us to take these reactions and cut them in half. And what I mean by that is we're going to do a half that involves an element that gets oxidized and a half that involves an element that gets reduced. If you do that, you'll find that balancing these are quite simple. So let's just take this first one. So in this first reaction, here's one half, sodium goes to sodium plus, sodium plus, and then the other half is chlorine goes to chloride. Okay, of course I want to balance that, right? So there's two half reactions. Let's do the other half. All right, in this one, so we've got SO3, 2 minus, and that's going to yield SO4, 2 minus. So there's one half, and then the other half would be MnO4 minus and Mn2 plus. Okay. Now don't worry about right now the fact that there's no oxygen over here on this side, and that the sulfurs are balanced and the oxygens aren't balanced. We're gonna wait till I teach you the rules of balancing redox. But just being able to split these in half is a skill that's important. So in this case, sulfur right here, sulfur's let's see, what would sulfur be? Plus 6, and over here it would be plus 4. Okay, so that's the oxidation half, and manganese is going from plus 7 to plus 2. That's the reduction half. All right, so hopefully this makes sense. The next thing is the big one, and that's where we're going to start balancing these redox reactions, and we'll go from there. So if there are any questions, feel free to ask. See you tomorrow.